All right, welcome to the Oakley Roll&O Lab. Here we've taken an R&D facility that we had in-house in Orange County, California. What we've done with this truck, though, is brought it on the road to show the public exactly what Oakley's all about. So this first set of testing we're going to do here is going to deal with optics. And all these tests are designed around the American National Standards Institute. You know, it's very important that sunglasses are tested. That way they can have some kind of a performance standard. And some of the things that are important to optics is that these glasses are going to protect you from harmful invisible light set off by the sun. And what UV does is actually burns your cornea or your retina of your eye, causing you to eventually develop diseases and things like that. So that's very important. So they test on that. This first test right here is going to be laser. And what this replicates is how light travels from a focal point into your ocular cavities. So right here we have an Alderson head form, which is the average of all head forms across the world. And with this head form we have two eyes. And these two eyes have two lasers coming out of them. If you look down there, you can see that one laser on that chart right there. As I walk down here, you can see these two paths of light right here. These two paths of light come together at one focal point. So this is how our eyes work. And the common problems start off basically with the design. Sunglasses over the years have evolved into these cool wrap shapes. And the problem is the wrap creates a curved surface or a curved lens for light to travel through. We all know that a flat plane of glass will allow light to travel straight through, but once you put a curve to that surface, it's going to bend light, causing prism. This is our first pair we're going to test. It's a leading competitor, and it has a nice wrap to it. Watch what happens to that light. It gets spread apart. We call that a horizontal prism. Light's hitting this lens and being directed outward. So now your eye must refocus on a constant basis to get that back to a correct position so you can see properly. This one has something we call rake. Rake is this forward angle right here. It goes down. And rake tends to cause vertical prism, or the bending of light vertically. So once again, your brain and eyes must now compensate for that flaw in that lens. And one thing to note too is vertical movement's more difficult for your eyes and brain to compensate for than horizontal movement. Oakley, going into this whole process of manufacturing sunglasses, have done things to correct for those problems. So we still have that big wrap. We also have a forward angle we call rake. But at the same time, we put these on, and you can see that light stays focused. What we've done here is develop technology called XYZ optics. And what that is a lens geometry. What we've done is actually concentrated lens material in the optical center, so it's actually thicker right here. That thicker material actually draws more light. Just like in science class when you're a little younger, you might have learned that you have two cylinders of glass sitting on a windowsill. The cylinder of glass that has more water in it is going to draw more light. So if you put more material in the optical center of this lens, it's going to draw more light. But at the same time, you don't want light to come over here to be overcorrected or redirected too much. So what we've done is tapered it. So coming from the optical center, it gets thinner and thinner and thinner and thinner, going out every direction from that center. And what that does is allow the lens to be rebalanced. So no matter what direction light hits this lens, it goes through a straight natural path, not being altered by the lens itself. And with this scope right here, we've created 35 feet of distance using a series of lenses. Our goal is to see that target as clear and as defined as possible. For the highest levels of ANSI testing, our goal is to see 20 lines of resolution, which is this series right here. This is our first material, glass. Glass typically is thought of as being very optically correct, but not always the case. You can see it's not as clear as you might have expected, coming from a name brand sunglass. Second material is CR39. CR39 is the most commonly used material in sunglasses today. Everything from a mid-range price point all the way up to your highest end fashion brands use that. You can see what that looks like right there. Now we get to polycarbonate. Polycarbonate is very common in any kind of sport or active application. Polycarbonate has a wide range of performance, from performing pretty poorly on this pair all the way to an Oakley polycarbonate, the highest grade polycarbonate in the world. We call it Plutonite. This is our high velocity test. We're going to take a 1/4-inch steel ball and shoot it from 8 inches away at a rate of 150 feet per second. That's equivalent to 102 miles per hour. Right here, we're going to test a tempered glass lens with a hard coat, something equivalent to any kind of glass lens sold as a sunglass on the market today. So here we go. You can see that shattered very easily. Oakley refuses to use glass in any of their lens materials because glass is not safe to wear. So same test, different result. You can see in that lens there's a slight pressure point created, but there's no cracking, fracturing, or breakage. Our second test is going to be right here. This is going to be high mass. So instead of having a small object moving very fast, we have a larger object moving a little bit slower. This is a 500-gram pointed steel projectile. We're going to drop this from 130 centimeters directly onto the lens. We're testing a CR39, which is probably one of the most common lens materials out there in the market today. All of your fashion, sport brands that don't use polycarbonate would use a plastic like this. You can see, just like glass, this kind of plastic tends to shatter with enough impact. Here's our Oakley lens. and you can see that even though that lens has been dented, it doesn't go all the way through, so you're still protected. There's 3 criteria that are required to pass these 2 tests, and they are the lens or frame cannot fracture or crack in any way. Also, no part of the lens or frame can get pressed back far enough to touch the orbital of your eye or your eyeball plus the soft tissue around it. And thirdly, the lens can't eject from the frame, and this lens is made to come right out, just like that. So now you can go to your local shop and get a new set of lenses as opposed to getting a whole new set of glasses or a new set of eyes. Thanks a lot for coming out today and joining us out here in Vancouver in the Rolling O Lab.